You are welcome to SAPAS International College. Subscribe to this channel, like the video and share it to your friends. This channel will help you to study chemistry and mathematics. And as time goes on, we shall also introduce you to physics and aspect of integrated science. I'll be grateful you share this video and you subscribe. Today we are going to talk about a very important topic, which I normally call the heart of chemistry. For you to be very versed in chemistry, you need to understand this concept of chemistry, which is called chemical bonding. So today, that is going to be basically the topic of discussion. So for us to begin, whenever you hear the term chemical bonding, what comes into your mind? A bond is an agreement. So whilst we are at the basic school, we study something about the bond of 1844. That is the agreement between the Fanti chiefs and our colonial masters. So when it comes to chemistry and we are talking about chemical bonding, all that we are trying to talk about is the agreement between these bonds. And before there will be agreement, there is a force of attraction. There should be some force of attraction. So that is what we are going to talk about basically. So if you are asked to, let's say, define chemical bonding in a very simple context, you can say chemical bonding is the force of attraction that exists between atoms or group of atoms. That is force of what? Attraction that exists between atoms or group of atoms. In other sense, we are talking about molecules. So anytime there is a force of attraction between atom and group of atoms, for instance, this water molecule, if you pick this water molecule, the force of attraction existing between this oxygen and this hydrogen. This force of attraction, or the line drawn here, is what we call a bond. So anytime we see these lines in chemistry, we are talking about a bond. Okay, so this is one atom. If there is another force of attraction existing between this and that, between these atoms, then we can say that is also chemical bonding. So it is the force of attraction existing between atom or group of atoms. That is in a very simple manner. The interest of this topic is to talk about the types of chemical bonding. Someone may ask, how many types of chemical bonding do we have? There are so many types of chemical bonding. But basically, if you are asked to state maybe 3 types of chemical bonding, someone will say ionic, covalent, metallic. But in today's video, we are going to clarify, or we are going to throw more light on these types of chemical bonding so that you not be confused. So basically, we can see types of chemical bonding or types of bonds. So basically, these are the types of chemical bonding. We have what we call the primary bonds or interchemical atomic bonds, and then secondary bonds, or what we call the intermolecular bond. Now, another name for this interatomic bond is what we call intramolecular bonds. So, in your various textbooks, you may see intramolecular or interatomic or primary bond. It's the same thing. Under these primary bonds, we can also get these bonds under these primary bonds. So, these are the basic primary bonds: ionic bonds, covalent bonds, and metallic bonds. Now, under these secondary bonds, we also have what's called dipole-dipole, hydrogen bonding, and then the LDF, which we call the landing dispersion forces. Now, when you say landing dispersion forces, we are referring to the van der Waals forces. Under this, we also talk about what we call dipole-dipole and induced dipole. So, today's video, we are going to concentrate on the primary bonds, starting with the ionic bonds. One thing you need to understand is that we'll be talking a lot about these ionic bonds. The covalent bonds, we'll talk about it. We have the polar covalent, non-polar, and then the dative covalent bonds. We'll talk about them. And then we'll also look at the metallic bonds. So let's begin with the first type of primary bonds. But before we do that, let me lay emphasis on this. In case you are asked to mention types of chemical bonds, you can just say ionic bond, covalent bond, metallic bond. If you are asked to state three, you can just mention ionic bond, covalent bond, metallic bond. All these are primary bonds. So it means that these types of bonds have been categorized into two main. But the examiner is not requiring or asking you to write, let's say, examples of primary bonds. You can, in a simple context, write these types and even add it. So if we are asked in exams, mention 4 types of chemical bonds, you can easily say ionic bonds, covalent bond, metallic bond, hydrogen bond. Someone will write ionic bond, covalent bond, metallic bond, and hydrogen bond. So whilst we study, we look at the strength. We can say emphatically that these primary bonds are stronger bonds compared to the secondary bonds in terms of the force of attraction. So we are going to, after the video, we shall be looking at the strength of these bonds. We will look at it, which one is stronger than the other. So that one, for this time around, you can generalize by saying that these primary bonds are stronger than the secondary bonds. Let's talk about the first primary bond. So we are going to talk about ionic bonds, or ionic bonding. Now when you say ionic bond also has a very nice name which we call electrovalent bond. So another name for ionic bond is electrovalent bond. So take note of this. In case you are asked to explain an electrovalent bond, we are still referring to ionic bond. So what is ionic bond? There is a special force of attraction which exists between this ionic bond or this electrovalent bond. And that force of attraction is called an electrostatic force of attraction. So in a very simple context, if you are asked to define an ionic bond, you can, in a very simple context, put it in this way: that an ionic bond is the electrostatic force of attraction that exists between atoms, that is one positively charged atom and a negatively charged atom, to form a stable compound. So what it implies is that for this ionic bond to be formed, we need a positively charged atom and a negatively charged atom. And these two atoms will come together to form a stable compound. So what is the main focus of this bond formation? Bonds are formed as a result of stability, or they prefer to be stable in nature. So that is the concept. And this ionic bond will enable us to draw structures of various molecules, making them stable in nature. And this concept is coined or propounded by this scientist Lewis theory. So we'll be looking at the Lewis dot structures, how to draw these Lewis dot structures for the various molecules. Now, let's discuss the ionic bond indicators. Let's assume we have these two elements, sodium and chlorine. For us to do this in a very simple manner, we need to write their electronic configurations. In writing of electronic configuration, in the electric chemistry, we prefer using the SPD notations. So let's use the SPD to write the electronic configuration of sodium so that we can get a concept work. So let's look at this 1s2, 2s2, 2p6, 3s1. This is the electronic configuration of sodium. Now let's look at that of chlorine. This is having atomic number 11, sodium. Chlorine has atomic number 17. So in writing of this, we are going to get 1s2, 2s2, 2p6, 3s2, then 3p5. Now, if you look at these electronic configurations, in chemical bonding, one important thing you need to understand is that anytime we are dealing with chemical bonding, we only use the valence electrons. Only valence electrons are used in chemical bonding. So for bonding to occur, we are only interested in the valence electrons. So the outermost electron is what matters. So if you look at this sodium, you realize that its outermost electron is the 3s1. That is, it has only one electron at its outermost shell. If you look at chlorine, for instance, chlorine is having 3p5 here, but we cannot classify this 3p5 as the valence electron. Why? Because this whole thing, look at this, this is having the same principal quantum number. That is 33. So in this case, we can easily say that the valence electron of this chlorine is this 2 plus 5. So chlorine has 7 as its valence electron. Take note of this. Do not say that because this is having 5, so that is 5. No. Consider the principal quantum numbers. We use this because this quantum number is different from this. This is 2 and this is 3. So you cannot say this is having 6 plus 1. But you can only say that for this because these have the same principal quantum numbers. So that's for chlorine. But in our core chemistry, we were taught this simple configuration. That is, writing of electronic configuration, we can use this in our core chemistry, which is 2:8:1. So in a simple context, when we talk of electronic configuration, we mean the arrangement of these electrons around the nucleus of an atom. So that is it. And you can also write this as 2:8:7. So you can see clearly that this has 1 and this has 7. Now, we are interested in forming ions with them. So you can see this sodium will lose 1. Already, I've said that chemical bonds are formed as a result of stability. So for these compounds to come together as stable entities, they need to what? Come together losing their charges. So I will quickly draw the curtains on this topic. Watch the next video so that you get more concept on this. Quickly, this sodium will come together as this sodium chloride. So sodium chloride is an example of an ionic bond. In my next video, we are going to look at how to write the Lewis dot structure of the various molecules. Thank you for watching this video. Subscribe, share, and like the video. Thank you. See you in the next video.